Hi everyone and welcome to today's tutorial. In this video, we will be tackling an interesting coding problem from LeetCode called reverse string. Well, this problem focuses on reversing a string in place using a two-pointer approach while maintaining the big O of 1 extra memory. Reversing a string may seem like a straightforward task, but it provides an excellent opportunity to explore fundamental concepts in programming, such as array manipulation, pointers, and efficient algorithms. By understanding this problem and its solution, you will not only strengthen your Python programming skills, but also gain insights into problem-solving techniques. In this tutorial, we will break down the problem step by step and explain the intuition and code behind the solution. We will delve into the details of each line of code, discussing the syntax, mechanism, algorithm, semantics, and logic behind the scene. And by the end of this video, you will have a solid understanding of how to reverse a string in Python with optimal time and space complexity. Excuse me. And before we proceed, please make sure to subscribe to this channel and hit the notification bell so you won't miss any future tutorials. So without further ado, let's get started. The intuition behind this solution is to reverse the given string by using two pointers. By starting from both ends of the string and gradually moving towards the middle, we swap the characters at the left and right positions until the pointers meet or cross each other. The two-pointer approach allows us to reverse the string in place without using any extra memory. It takes advantage of the fact that we can swap elements within the same array without needing additional space. The intuition can be visualized as this. We start with the left pointer at the beginning of the string and the right pointer at the end of the string. In each iteration, we swap the characters at the left and right positions. This effectively reverses the order of the characters. And after swapping, we move the left pointer one step to the right and the right pointer one step to the left. We continue this process until the left pointer becomes greater than or equal to the right pointer. This condition indicates that the pointers have crossed each other or met in the middle. The intuition of this solution is based on the observation that by swapping characters from both ends towards the middle, we can reverse the order of the characters in the string efficiently. Now, let's go through each line of code step by step. The first line, def reverse string. Well, this line defines a function called reverse string that takes an array of characters S as input. Left to 0. Well, this line initializes a variable left with the value of 0. It represents the left pointer starting from the beginning of the string. And right to len S minus 1 or subtract 1. While this line initializes a variable right with the value of len S subtract 1, while it represents the right pointer starting from the end of the string. The len S function returns the length of the input string, and we subtract 1 to get the index as the last character in the array. And while left less than right, well, this line starts a while loop that continues as long as the left pointer is less than the right pointer, and the loop will run until the two pointers meet or cross each other. And this line swaps the characters at the left and right positions in the string S. It uses a Python shorthand notation for swapping values. And by using tuple packing and unpacking, it swaps the values without needing a temporary variable. And this line increments the left pointer by 1, moving it to the next character towards the right. And this line decrements the right pointer by 1 and moving it to the next character towards the left. The overall algorithm follows a two-pointer approach. The left pointer starts from the beginning of the string, the right pointer starts from the end, and they move towards each other. In each iteration, the characters at the left and right positions are swapped and the pointers are updated until they meet or cross each other, effectively reversing the string. It's important to note that the algorithm modifies the input string in place without using any extra memory, which satisfies the requirement of big O of 1 space complexity. While the space complexity of this solution is constant, it uses only a fixed amount of additional memory regardless of the input size. The algorithm modifies the input string in place without using any extra data structures. Thus, the space complexity is big O of 1, satisfying the requirement of big O of 1 extra memory. The time complexity of this solution is O of n, where n is the length of the string. The algorithm visits each character once, performing a constant number of operations for each character, and therefore the time complexity is directly proportional to the length of the string. So in summary, the solution has an efficient time complexity of big O of n and a space complexity of big O of 1. It reverses the given string in place, meeting the problem's requirements of using big O of 1 extra memory. And that concludes our tutorial on solving the reverse string problem from LeetCode. Well, actually, reversing a string may seem like a simple task, but it serves as an excellent exercise to sharpen your problem-solving skills and enhance your understanding of array manipulation and two-pointer techniques. Remember, the two-pointer approach is a powerful technique that can be applied to various problems and not just string manipulation. Understanding the logic and intuition behind this approach will help you in tackling other coding challenges that involve working with arrays or sequences of elements. If you have any questions or suggestions for future topics, please let me know in the comments section below. And your feedback is highly appreciated. If you found this tutorial helpful, please give it a thumbs up and share it with your fellow programmers. Also, please don't forget to subscribe to this channel for more coding tutorials, algorithms, explanations, and problem-solving strategies. Thank you for joining me in this tutorial. Happy coding and best of luck with your coding journey. Goodbye.